Hello there, my name is Erik Robbins. I'm going to be discussing my ME6225 project on my metrology story, and the one I've chosen to do is the legend of Archimedes measuring the gold wreath. The legend goes that in the 3rd century BC, Greek mathematician Archimedes was tasked by his king, Hero II, to inspect a gold wreath to ensure that it was 100% gold. The king suspected that the goldsmith had shortchanged him and instead substituted silver or some other metal when melting the wreath. Obviously, the crown had great value, so the test had to be done in a non-destructive manner. Initially, the legend says that Archimedes was stumped by the problem until he decided to take a bath. During his bath, he noticed that when he got in, he displaced water, which caused it to fall over the edges, thus discovering the Archimedes' principle, which is that of displacement. In his excitement, he ran through the streets of Syracuse, yelling "Eureka, Eureka," which is where the term is most often credited. The plan that Archimedes essentially was supposed to have used was to find a gold nugget that was equal in weight to the crown, and then see how much water it displaced from a watered container compared with that of the crown. Since they have the same mass and they were supposed to be the same material, you would expect them to displace the same amount of water if their densities were truly the same. Instead, what they found was that the amount of water displaced by the wreath was actually greater than that of the nugget, which confirmed that the wreath was not made of 100% gold. And the goldsmith later admitted that he had included silver and was later punished by the king. It's a really fun story, and it's very much comparable to other so-called flash of genius moments, such as Newton's discovery of gravity after he was hit in the head by an apple. Unfortunately, it's probably not true. The first hint of this is that Archimedes himself never actually wrote of this event. Instead, it was done by 1st century BC Roman architect Vitruvius, so obviously there was several hundred years between the telling of the story and the actual event. And more importantly, while the science is theoretically sound, it's really difficult to imagine that Archimedes, with the tools he had at the time, could have done this experiment and fairly concluded that the wreath was not 100% gold. There would most likely be multiple sources of experimental error that would account for more than any changes in displacement that Archimedes would witness between the wreath and the golden nugget. These include surface tension, air bubbles that might be immersed on the objects, and water clinging to the objects as they were removed. This slide goes over a series of calculations that kind of demonstrate that the difference in displacement would probably be much, much less than any of those sources of experimental error. With some fairly reasonable assumptions, such as a 30% silver cut by mass for the crown, 800-gram crown, and a container that would have to fit the fairly large crown of 19 centimeters, it can be shown that the volume of both the crown and the nugget relative to the cross-sectional area is pretty small. There is a difference of about 10 cubic centimeters between the crown and the nugget, but due to the large cross-section of the container that you would need to hold the crown, the difference in displacement comes out to only 0.37 millimeters. It's hard to believe that with the tools of the era and the sources of experimental error, that Archimedes could have realistically been able to tell the difference between these two objects. Had he done the test, it's probably likely that he would have concluded that the crown was in fact made of 100% gold, even if it were not. Now that doesn't mean that Archimedes would not have been able to reach the correct conclusion. He just would have had to use a different experimental setup. Had he employed the concepts of buoyancy and the lever that he was very famous for, he in fact could have proven that the wreath and the gold nugget were, while equal of weight, different in density. First, he would have used a scale to equalize the weight between the nugget and the gold wreath. And then you would immerse both the nugget and the gold wreath in a bath of water. And due to buoyancy, you would expect that the scale would tip one way or the other if there was a difference in densities, if there was a difference in the density of the two objects, and if not, then it would remain stationary. The reason that this would work whereas the previous experiment would not is that the difference in density between water and metal is quite large and results in more of a difference in buoyancy force. And also, scales at the time were probably one of the most accurate forms of measurement, which is pretty understandable considering that most bartering took place over commodities, and you would have to make sure that they were weighed properly in order to get proper payment. To demonstrate that this would work, let's look at the same numbers from the previous round of calculations from the other experiment and apply them to this method. The initial assumptions stay the same. We keep the crown as a 70-30% mix by mass between gold and silver. The nugget and the crown still weigh 800 grams, and we also add in that the density of water is 1 gram per cubic centimeter. The volume of both the crown and the nugget, not surprisingly, stay the same. Next, we can calculate the apparent weight of both the crown and the nugget, as shown, and you can see that the difference is relatively small, 7.3 and 7.4 newtons. When converted back to mass, this equates to a difference in 12 grams between the two objects. While this isn't much, it would have been enough to tip the scale in the direction of the nugget, thus demonstrating that the crown had not been made of 100% gold. I think there are a number of takeaways from this presentation. The first off is that sometimes a measurement technique which makes sort of the most intuitive sense might not be best for each application. For some applications where the container you would use would be relatively narrow, Archimedes' technique would have most certainly worked. But of course you have to match the technique with the actual application. The next point I would illustrate is that the tools available to engineers and scientists are often one of the biggest restrictions towards doing our jobs. Unfortunately, in the real world, you're almost always resource limited in what kind of tools that you have. And so it's important to remember that you have to be flexible and think of alternative ways of doing things such as measurements based on what tools you have available to you at the time. That's the end of my presentation. Shown are the resources that I used for research. Thank you, and have a good day.